In this video, we're going to talk about topic 5.3, which is solving linear quadratic systems. So this is something that is brand new to you. So we are going to answer the question, how do you solve a linear quadratic system of equations? And by the end of the lesson, you're going to be able to, your I can statement is, I can solve a linear quadratic system of equations. So we're going to do a little bit of investigation about solutions of equations right now. So there are many real-world situations that can be modeled by a linear or quadratic function. What happens when the two situations overlap? Examine the graphs of linear and quadratic functions and determine the ways they could intersect. So they just want us to look at this graph of a horizontal line and the graph of a parabola and draw the ways that they could possibly intersect. So the first way would be maybe where we've got a parabola like this. So they're actually wanting us to use that particular parabola, which looks like it's about right here. Oh, maybe not. We don't have to necessarily use that one, but a parabola and a horizontal line. So we're going parabola, horizontal line, so they could intersect in one place. If I drew another parabola and I shifted up my horizontal line, they could intersect in two places. And then the only other situation that I can think of is we draw a parabola and a horizontal line and they intersect in no places. So a constant function and a constant linear function and quadratic function can intersect at 0, 1, or 2 points. So the reflect question asks, if a line intersects a circle at one point, what is the relationship between the line and the radius of the circle at that point? So if I were to draw a circle and a line that intersects the circle only at one point, and then I drew the radius out to that, do you notice that, I know mine's a little crooked, but do you notice that they're making a 90-degree angle? So it would mean that they're perpendicular. It's actually a property from geometry. And then the discussion, does a line have to be horizontal to intersect a parabola at exactly one point? So let's go back up here to our pictures and let's see if I can draw another parabola and see if I can get it to intersect at exactly one point. So I could draw it like this. I could draw a vertical line and get it to exact, so it does not necessarily have to be horizontal like that to intersect. So it could look like a line. It could look like a line that has some slope to it, or it could look like a line that has that's undefined. So I would say no. You can draw a line with a slope or vertical. All right, so another gift. I gave you a gift yesterday. We are not going to do explain one, so you can go ahead and go to the next video where I skip all the way down to explain 2. We're only going to do this algebraically.